So in the last video, I mentioned that for the first project we do here, it's going to be based in Python and how Python is the glue that kind of holds the whole network automation world together, I believe was the term I used. And that's great. What allows Python to do that is how extensible Python is. By that, I mean when you download Python, it comes with a set of libraries that allow you to do basic things. You can, print to the screen, do basic arithmetic, all the normal features of a programming language. But if you want to add to that, if you want to have the ability to have your program SSH into a device or run API calls to a web URL, you do that through adding libraries to it. So it's very extensible with these libraries. But the issue you run into with that is, say you're working on a program for yourself and you have these libraries that you're using. They're the latest versions of it and it's great and it's working. Well, you also want to download some other code from the internet. So you go to GitHub, you download somebody else's code for another project, and this code's a little bit older, but it still works. But the problem is the libraries they're using are different. They're either a different version or there's some compatibility issue. So how do you manage that? Because Python is so extensible and you can have so many different libraries and versions, it's really flexible, but you're also going to run into conflicts really quickly. So how Python does this is something called virtual environments. So if you think about it, how are you going to do that? You could install a virtual machine on your computer and run a completely different instance of your operating system and have a different Python, but that's clearly not a good way to do it and not very good in the long term if you get a whole lot of those. So what Python does is it has these virtual environments, and you create a virtual environment and it's just a directory on your computer. And within that directory is the Python executable, the specific Python version you use to create it is there, and then all the libraries you used are there as well. So the specific libraries that you were using for your code or somebody else is using for their code, they're all present within that directory. So you can have a set of 20 different of these virtual environments and 20 different versions of these libraries, and none of them are going to conflict with each other, and you're able to keep this all separate. So it's a really good way of doing it. So let's take a look at how you're actually going to do that on the command line. Okay, so here we are on the command line, and we are going to get started and install our Python virtual environment. So the first step is to have Python installed, which I have done here. So I have Python 3, which is the current version of Python. So Python 3. Virtual environments in Python 2 are a little bit different, but we're not going to go over that. We're sticking with 3 as it's the current version. Python 3 -m for module, virtual environments. We're going to run the virtual environment module, which is going to create a virtual environment for us. And here you specify your path to virtual environment that you want to create. I don't need to do a full path here because I'm going to create it within the folder I'm in. I'd recommend either keeping all of your virtual environments together in one folder by themselves, or keeping it in a folder next to your code, which is what I'm going to do here. What I mean by that, by next to, is I'm going to create SNMP Polar virtual environment. That's what we're going to create. We're going to make an SNMP Polar. And so now it's created that virtual environment folder for us. I'm going to make another folder called SNMP Polar code. So next to, you don't want to put your virtual environment in the same folder as your code. It just gets really messy that way. So do it next to, or keep all your virtual environments in a folder by themselves. So now we've created that, and the next step is to activate it. So to activate it, it's a little bit different on Mac and Linux, and Windows. On Mac and Linux, it's going to be source SNMP Polar virtual environment, which is what was just created, bin for binaries, and then activate. And you see it actually changed my command prompt here. And now it's letting me know that I am within the SNMP Polar virtual environment. So anything I install here, anything I do with Python, is just going to be for this virtual environment. On Windows, instead of using that source program, within that folder that was created for your virtual environment, there's going to be a bash file called it's called scripts and then activate.bat. You'd run that. But same idea, just a little bit different way of doing it. So now that we have our virtual environment created and we're running it, the next step is to install some software we need. So that is all done through the Python package manager, which is called pip. So pip is a really easy way to install Python packages. Let's see what we have. So pip list will show what's installed for the virtual environment you're in. And not much, just the defaults. I have pip, I have setup tools, and it's also telling me here that I can upgrade pip, that whatever version I'm on now is out of date. We'll get to upgrades in a little bit, but I'm not going to do that quite yet. So I want to do some installations first. So what I'm going to install is I'm going to install a program called Requests, or a library called Requests. And what Request does is it makes API calls. We're going to end up using this a lot. So pip search requests, and that's going to show us, here's the one we want. There's a lot of different, it's going to show you all the different libraries that have the word requests in them. We just want the basic one called request, which is Python HTTP for humans. That's how we're going to do API calls. And it says package 2.23.0 is available. But say I don't want to do 2.23.0. Say that has some feature that's going to break my code and I know about it. So I want 2.0.0. So to install it, you do pip install requests. If I'd hit enter right now, it would install 2.23.0. It defaults to the latest one, but I don't want to do that. I want to do an older one. So let's do equals equals 2.0.0. All right, so now it's said it successfully installed it. So let's go back up and look at pip list. And there you can see we added requests 2.0.0 to that. But so let's go back to that upgrade part. So say we decide, well, actually requests came out with some really cool stuff in their new version and we need to get that latest version, that 2.23.0. So to do that, pip install, and we're doing the same thing it told us to do for pip itself, upgrade, minus upgrade, requests. So pip install minus upgrade requests, and it is going to upgrade that library. So this gave us a little bit more. It's saying it installed some other things here. It installed something called Certify, which is for certificates, URLlib, so some other libraries. So let's look at our pip list. So you can see here that when we installed the newer version, so there was actually a lot of changes between 2.00 and 2.23.0. So with this 23 version, it had some dependencies where this request library is going to, on the back end, use some of these other libraries. So it installed those as well. So that's pretty handy. So it can take care of all of your dependencies for you. So if you install one library and it needs 5 others, it'll do that for you automatically. So that's pretty nice. And if you want to know, how did I get all these things installed? Where do all these come from? What needs these? I can do, oops, not show, network engineer in me coming out, pip show requests. Here you go. And it says you're currently running request version 2.23.0, description, homepage, author, and then you can also see everything it requires. So these are all the libraries that it installed. And then you can see required by, this doesn't have anything in it, but if I do certify, you can see, that's why I have it installed, because I'm using requests. So if you ever wonder why you have some libraries installed or what's using what, you can use that pip show to see all that. So say I write my code and everything's working and I want to give this to somebody else. So how do you do that? Do you tell them, okay, so you need to go in and you need to pip install all these things? It's kind of an annoying way to do it. So we want something a little bit more streamlined than that. So pip lets you do something called pip freeze. And what pip freeze is going to do is it just outputs this. You remember when we did the specific version, when we installed version 2.00, how we did that? We did pip install request equals and then the version. That's what you see here. So you see all of your installed libraries with that equals and the version number. So how does that help us? Well, if you do pip freeze, I don't know where I am in my bash history there. pip freeze, and then output that to, you can name it whatever you want, but the normal thing to do is requirements.txt. So now, when I look, I have my requirements.txt. And if I cat that, there you go. I have all my libraries in there. So how do we use that? So when you're distributing your code to somebody else, or when somebody else is giving code to you, and you have a requirements.txt, so let's deactivate, which is what quits the virtual environment. Now you see my command prompt went back to normal. I'm no longer in my SNMP Polar virtual environment. Let's go ahead and create a new one. So once again, that was Python 3. Python 3. Module virtual environment demovenv. So we're just creating a virtual environment called demovenv. So source demo bin activate. So now, instead of being in our SNMP Polar virtual environment, we're in our demo one. So if we go back and do pip list, what do we see? We are back to our basics. So all we have is the pip and the setup tools. So say we have this requirements.txt. How do we install that for our demo virtual environment? Install -r, because that's going to be our requirements, and then your file, requirements.txt. What that's going to do is it's going to do an install on each of these entries in that file where it created for us. So we get the exact versions that we need. Oops. Is it not -r? Pip install -r requirements.txt. Let's try that instead. There we go. So now it goes through and it's going to install those for us. So now when we do pip list, we have all those installed properly. And you do want your requirements.txt in with your actual code, because that is what you want to distribute. So when you go and you distribute your code to somebody else, you don't want to actually give them your virtual environment. You just want to give them your code, and you also want to give them your requirements.txt. And then with that, they can go through and they can get the exact system you have, so they're sure that it works. So it's a really handy way of keeping track of a lot of different moving parts, and you can have many different virtual environments in there. And once again, I'd really recommend you starting out doing this. It's good practice. When I started out, I wasn't using virtual environments, and I was just using the default Python. There's nothing that says you have to use a virtual environment. You can just install pip normally, but then you're going to end up with a lot of things conflicting and some really messy code. So it's really good practice to start out using this. It's a really powerful tool and it's easy to use. So in our next video segment, what we're going to be looking at is installing Visual Studio Code and writing code from there, and how to use these virtual environments within Visual Studio Code. I hope to see you there. Thanks. Bye.